There are three speakers, and I'm going to introduce them backwards. We have Murali Gulaganti, we have Shalini Goval, and Mr. T.V. Raman. So I'm going to go backwards and introduce Mr. T.V. Raman first and foremost, who's a research scientist and a Google accessibility researcher at Google. And I have a lot of personal respect for Mr. T.V. Raman because he does a lot of testing on our products, including on Google Home, which is one of the products I work on. So I get a lot of good feedback and insights from him around accessibility. He has filed about 75 patents on his work on eyes-free interaction, which has been profiled in mainstream publications, including New York Times. Raman has a MSc in Math and CS from IIT Bombay, and he has a PhD at Cornell University. Fun fact about him is he's able to solve the Rubik's Cube at an average speed of 30 seconds. So that's pretty incredible. Yes, that deserves a round of applause.
Hi, Shalini. All right. Tilly, come back to me. Yeah, just a minute. Let me settle down. Tell him sit.
You want to sit?
Yeah, no, I'm settling him down. All the way. I'll just stand. I'll be fine. So that's the clicker.
Yeah.
That button.
This is forward.
That's forward.
And
Okay. No, I won't bother with the other one. I'll just, that's forward, right?
Sure. And I'll come to
Okay. Is my mic on? I guess it is. Hello, everyone. My name is Raman. I work at Google. I currently work on the Google Assistant. First of all, thanks everyone for coming on a Saturday morning when the weather is gorgeous outside. This is a tough bar to meet by giving a talk at this kind of time. So welcome. What I wanted to talk to you about was about 30 years of work starting from grad school on this adventure called eyes-free information access. And what I mean by eyes-free information access is using speech and accessing information in hands-busy, eyes-busy environments. And it's becoming obviously even more relevant today as computing becomes more ubiquitous. So the way I do my talk is I always say what I'm about to say in the beginning, I say it in the middle, and I say it at the end. So this is the overview of the talk. We'll talk about the goals of the work in the first section. We'll talk about some of the insights gained during those years of work in the second section. And we will conclude. So high level, this talk is about realizing that information that is electronic can be more than just looked at. First of all, it can be interacted with, as all of you have gotten used to. More importantly, you can interact with it visually, auditorily, with a multiplicity of modalities at the same time. And as you do that, the information goes with you everywhere. So let's go to the next section of the talk. So this is the goal section. So the goal is effective information access in an eyes-free environment. So what does that mean? So this journey started 30 years ago. And think back to the computing environment of the time if you can. So I started grad school at Cornell in 1989. So most people think the internet came in the early 90s. The internet was already there in 1989. It was called the NSF backbone. You had FTP, HTTP was just being invented. And so when you sat in your office in grad school at the time, it felt like sitting on a very lightweight chair perched on top of a jet engine, right? The plane hadn't started flying, but you knew that it could. And so as I looked at the space at the time, the thing that really motivated me was, I said, there's all of this information. This information is computable, and we'll talk about that very soon as to what that means. And this information can go everywhere. You can get access to it everywhere. Remember, at the time, you still needed to go to that PC sitting in the corner of your office to get at that information. But it was obvious that that wouldn't be the case all the time. So the journey I started on was information access when you want it, where you want it, and the way you want it. So let's go to my next slide. Hopefully, I'm still in sync. So I've sort of written out some of the things that I did. And you sort of follow this time continuum. In some sense, what you do is always a function of the environment around you, right? So you do what everybody else is around you, where the innovation is. So the first thing that I built, which was my PhD thesis, was a system called Aster. It was called Aster because it was named after my first guide dog. The thesis hard problem was to come up with an expansion that made sense. I called it Audio System for Technical Readings. Now, this was a very niche application. What it did was it provided you the ability to read electronic books, browse them, interact with them, with a special twist. It focused on technical books, so math content. I call it a niche application because not everybody wants to sit around listening to math content, but it was a wonderful PhD project because it exposed a lot of the underlying problems. So then I came to California and now started becoming a little more practical, mainstream oriented. I worked at Adobe, and there I actually looked at getting high-level information out of PDF documents. You'd sort of say, what is the connection of that with audio? The reason this was important is that if you want to provide eyes-free information access and do it effectively, you first need access to that information. And since a lot of the world's information was going through the print medium, through PostScript into PDF, I worked on that for about 4 years. Then I went to IBM, IBM Research, and worked on what was emerging as this vision on the multimodal web with, at the time, and the handheld was the the Palm Pilot and the iPac, and we were all speculating about whether it would be the smartphone that would win or whether the PDA that would win. Today, of course, you know the answer. So worked on, at the time on what I thought of as standards for multimodal computing. How do you represent information? How do you build these systems so that you can access the same information from different environments, different places, different user interfaces, different front ends? And then I came to Google, and that was about 13 years ago, and initially worked on the problem of presenting search results to the user in a form that was most convenient for that user. And as that work was happening, Android happened. So I started hacking Android and worked. And so now you had mobile computing, and suddenly this vision of eyes-free access and ubiquitous access was a very mainstream thing. And fast forward a little bit more, and today we are in the world of smart assistants and smart speakers. For my day job now, I work on the Google Assistant. And so look at the transition from that PC that sat in the corner of their room to a phone in your pocket that is essentially to your front end to the world of cloud computing, to the smart speaker that is sitting now completely invisible, doesn't even look like a computer. So that's the evolution we've gone through. Here is a list of insights that I've gathered as I have gone through this journey. And once we talk through this in the next section of the talk, I will deep dive into each of these. So the first insight was electronic information is display independent. What do I mean by that? So when I sat at my desk and wrote down these slides, I had some thoughts in my head. I have written them down. It has been transformed to a visual representation, colored marks on a background. And when you look at it, hopefully if I did a good job of typesetting my slides, and if I'm still in sync with my slides, those ideas that I had in my head have been recreated in your head, right? But if you just took this piece of paper on which that slide is printed, the ideas are basically dead until somebody looks at it. But when you move this to the world of electronic information, that information can be computed on, it can be searched on, it can be transformed, all kinds of wonderful things happen. So that was the first insight. The next insight was how you speak things is very different from how you print things or how you display things. So that started me thinking about treating speech as a first-class medium. From there, you went on to realize that it wasn't just about speaking information, it was building about interactive systems, which means applying the same principle to user interfaces. And then finally realizing that as you do different user interfaces, it's the UI peripherals that actually determine the size and shape of the devices you use. So let's go to the next section of the talk. So talk again about electronic information being display independent. I've tried to draw the simple picture for you where I'm trying to convey to you the fact that information as it stands is independent of how you present it. So let's take a concrete example, like take a weather forecast. The typical way you are used to seeing a weather forecast on your mobile phone or on your desktop PC is to see a table of numbers with weekdays at the top and high and low and a bunch of numbers. But that's not what you would speak, right? If I asked you what's the weather tomorrow, or ask the Google Assistant what's the weather tomorrow, it's going to say it's going to be sunny and 75 degrees. That's a very different representation. But notice that both representations are derived from the same underlying form. And if you were to then go look at this on your television, what you probably want is a high fidelity weather radar map or whatever, right? So information is display independent. You apply these transformations to it called print or speak, and you get the result. The next insight is about what is the user interface. So we all use UIs a lot. Here is my high-level way of thinking about user interfaces that I've again tried to draw for you. So you say user interface is how you interact with your application. So what is a computer application? It's some program that you wrote. And what is the goal? At the end of the day, the goal of user UI is to connect the human and the computer. And what does that mean? You, as a human, need to express your intent to the machine. That intent might be expressed by waving a mouse, pushing a button, or speaking, or pointing, or clicking. That intent then gets transformed into some form of data that the computer munges on, computes, turns into a result. And that result then needs to be presented to you in a way that it grabs your attention. It might speak to you, it might flash your screen, it might make a little robot dance, whatever, right? So this really is UI. And so when you think about UI this way, what you also then realize is that you can actually separate the underlying functionality of a computer application from how you interface with it. And then this suddenly opens up this whole space of how do you access the same type of content from a smart speaker to a smart speaker with a display, to a television, to a Chromecast stuck inside a TV as an HDMI stick, all the way to your laptop, to everything else. So let's go to the next slide. So stepping back, right, and going through the various generations of computing we've been through, I won't go as far back as punch card computing, but late 80s, you had the computer sitting on the corner of your office. So you had a monitor, a keyboard, and a mouse. Then you got laptops. And then so you carried around these laptops with LCD panels, and the world of computing changed. The world of computing changed again when you got smartphones and this nice shiny piece of glass. So nice shiny piece of glass, again, because that is the most practical way of implementing that interface. And then you went to speakers, and then soon now you'll go to wearables. So look at this evolution. So for instance, in the late 90s, early 2000s, when storage was getting really small, 1999, the IBM microdrive arrived, and we thought 1 gig of storage was wonderful in a small postage stamp-sized device, right? And so at the time, we used to say, you can put all your personal data on a stick or on a thumb drive or on a microdrive and carry your computing everywhere with you. Then networking became ubiquitous. Today we say you don't need to carry the storage. You can put all the information in the cloud, but we are still carrying around our displays. So as a thought experiment, I'd like you to think about books that are, stories that are staged in the late 1800s, early 1900s. And you will notice something interesting if you read Charles Dickens. People, when they go to rooms in the evening, when they go anywhere, they carry something that we don't carry anymore. They used to carry candles and lanterns. So 21st century, late 20th century, early 21st century, we are still carrying our displays around. I don't know how long that will last. Maybe the displays will be ubiquitous. Networking is ubiquitous. Storage is in the cloud. And you still basically communicate with these devices. So I'm going to my conclusion section. So to me, what we've talked through actually tells you something fairly instructive, which is the size and shape of your compute devices are actually determined by your UI peripherals. Storage can be in the cloud. Processors can be in the cloud. You can have a phone in your pocket that is basically your L1 cache or whatever. But at the end of the day, the size and shape of your phone, the size and shape of your Google Home speaker, the size and shape of that Chromecast stick that you stick in the HDMI port of your TV are all determined ultimately by the UI, the shape of the UI peripherals. And so the question is, where will we go next? Sensors around our body? Probably, right? Because remember, at the end of the day, UI is about you expressing your intent in a form that can be turned into data for the compute device, and for the compute device to turn the results it has for you into a way that it can grab your attention. So here's my final slide. This is my previous guide dog sitting on the pilot seat of a 767. I've always had this as my conclusion slide, saying the sky is the limit in terms of what you can build. So thank you very much. Tilted. Wake up, please.
Thank you very much, Raman. Please stay on stage. We are